This is the beginning of Chapter 2. Chapter 2, Structure and Functions of Cells of the Nervous System, is a huge chapter, both literally in pages and in content, more so in content. I'll be teaching this chapter in three very distinct chunks. First, we'll talk about the cells of the nervous system, then, communication within a cell. This is how a cell generates its action potential and sends it down to its own terminal. So it's this process. Then, communication between neurons is when we start talking about systems of neurons communicating with each other. Okay? These will be areas of great concern. The synapse. First, let's talk about some terminology. I want to make sure we're all on the same page. The largest unit, the thing that we talk about, is the nervous system. This includes the central nervous system and the peripheral nervous system. Now, under the central, we have the brain and the spinal cord. The brain we can split into the left and the right hemisphere, and each hemisphere into the four lobes. In the periphery, he split it down to the somatic and autonomic. Somatic, we're talking about sensation and movement. And autonomic, we're talking about sympathetic, which is your fight or flight, and the parasympathetic, which is all about bringing you back down to baseline. Mama? Make sure you know all these terms and where they all go. Before we get into neurons, their parts, and how they work, let's talk a little more broadly. We're born with roughly 100 billion neurons. The exact number is difficult to figure out, of course, and every brain's going to be a little bit different, but let's use that scale, 100 billion. Each one of these neurons is connected to thousands of other neurons. And because one neuron makes more than one connection with its neighbors, there's a total of tens of thousands, hundreds of thousands of connections per neuron. It's the network activation that leads to all the things that we think of as the mind. The details of that network activation we don't even fully understand. If I'm being honest, we don't understand hardly at all. But that's where we're headed. That's what we're trying to figure out. But as strange as it might seem, you are born with the greatest number of neurons you're ever going to have. It's basically going to be downhill from birth. A lot of what I hope you get from this class is an understanding that you have to take care of your brain. You have to take care of your nervous system because it's everything. It's everything. Your personality, your memories. Gosh, everything comes down to the very particular setup of your nervous system. So you want to protect this thing. Because you know what? The brain is unique. It is very difficult to repair after damage. Neurons are not made after birth, except for the hippocampus, which is it's the exception that proves the rule. It's so unusual that we've observed neurogenesis in the hippocampus, which is the birth of new neurons, that it shows you just how unusual it is, because the rule is, no, you don't make new neurons after birth. So neural health is very important to us because you're going to be about 100 years old before you pass away. And you're going to have essentially the same brain to take you through that entire journey. Now, connections between neurons change every day, all the time. But damage is permanent. So, how do we damage our neurons? How do we kill them? Well, head injury, of course, through sports, car accidents, violence. Also through drugs and overall unhealthy behaviors. But something, it's pretty easy to avoid head injuries for the most part. Don't play the sports, don't behave violently, and you can usually avoid a lot of it. Drug addiction is a big topic for this class, and we'll talk about that later. But something that we all do that hurts our brain is neglecting it. We neglect our brain, even though it is so darn important to our daily functioning and our lifetime success and failures. I'd like to use an analogy here because it's a lot easier for people to visualize what I'm talking about when we talk about muscles. If you want to get in shape, if you want to get fit, if you want to go from this to this, what do? You go to the gym. But there are different ways of going to the gym. Some people will go through the motions. They'll buy the membership and the clothes, but they'll go to the gym and they don't really put in the work. I say if you're just walking around looking at other people working out, giving high fives and attaboys and good job and so on, you're not going to get buff. You have to do the work. You have to put in the time. Because your body is very smart. Your body will maintain the minimum amount of muscle for your lifestyle. If your lifestyle is one where you don't do a lot, you don't move a lot, you don't lift things, you don't move things, then we're hardly using our body at all. In order to make your body grow muscle, burn fat, you have to challenge it, and pretty significantly. You have to go to the gym. You have to get some kettlebells. Get an awesome mustache, apparently. Because when your muscles are inactive, they will degrade to the minimum required for this person's lifestyle. Like picking up groceries from the car to the kitchen. Not a lot of work required. Typing, not a lot of work. In order to grow your body, to make it stronger, you have to push it. You have to push it hard. Now your brain is no different. You all understand that going to the gym and walking around isn't going to do anything. But a lot of students go through the motions of education. They sign up for the classes, but they don't do the work. They go to class, but they don't engage. There's no way your brain will develop. There's no way you will learn and grow without intense effort. Now, if I get fit, I go to the gym and I build muscle, and then I stop. This arrow is a two-way arrow. Your body will absolutely atrophy, eat away, devour, destroy, whatever you want to call it. It will break down these muscle fibers and break them down to their basic proteins and then to their basic amino acids, and then we start over and your body makes whatever it needs. Here's an image. You could see tons of these online. After your leg has been in a cast for a couple months, inevitably your muscles atrophy. Why? Because the whole point of a cast is to immobilize your bone so that it's allowed to heal without any stress. But your muscles react to whatever you're making them do. If you stop using your leg, this will happen to you, cast or no cast. If this guy or this guy or this guy stops exercising, they revert. Same with your brain. This is a lifelong challenge. If you want a fit brain, if you want a healthy brain, if you want a brain that's going to lead you to the top of your business, to the top of your field, you need to challenge it significantly. A few examples: learning a new language, learning a musical instrument, uh, getting seriously into art, things that are genuinely and truly challenging for us, learning a new math. But if you do this, if you push your body and you have a normal body, it will respond positively. Just like it will respond negatively if you stop pushing it. All right, next we'll talk about the neuron, its basic job, and its parts.